Let us see literature review of our project. Hospitals increasingly need autonomous robots to perform repetitive and time-critical tasks such as delivering medicines, transporting lab samples, and moving equipment. Traditional automated guided vehicles (AGVs) follow a fixed path and depend on centralized control, which makes them unsuitable for dynamic hospital environments where human movements and task priorities frequently change. Recent research on robot fleet management highlights that effective coordination of multiple robots requires flexible task allocation, traffic control, and real time communication. Studies emphasize that decentralized and middleware based systems are more suitable for complex environments like hospitals, as they improve scalability, reliability, and safety. Robot operating systems ROS2 is widely used as a middleware platform that enables reliable communication and coordination. Its navigation stack nav2 allow robots to perform mapping, localization, path planning, and obstacle avoidance, which are essential for autonomous movement in indoor environments. At the fleet level, OpenRMF provides mechanism for managing multiple robots by handling task assignment, traffic scheduling, and conflict resolution. This framework is particularly useful in shared environments such as hospital, where robots must safely operate alongside humans. From an intelligence perspective, recent studies show that artificial intelligence techniques, especially reinforcement learning, help robots learn cooperative behavior such as congestion avoidance and efficient task execution. Other methods like the A-star algorithm for path planning and neural network for predicting human movements further improve the system efficiency and safety. However, existing studies indicate that there are limited practical implementations that combine ROS to fleet management and simulation environments and AI based decision making into a single hospital focused system. Therefore, the project aims to address this gap by developing an AI driven multi robot hospital fleet management system using ROS2, NAV2, OpenRMF, and learning based methods in a simulated hospital environment. Thank you.
Now the last one is about traffic and congestion dataset, which includes how many robots are in an area, how long they wait, and if the collision happens, the data will reduce crowding and avoid accidents. And the next one is about human movement datasets, which shows how people move in hospital corridors. This helps the system predicts where people will move so robots can move safely. Now the last one is about traffic and
Hello everyone, I'm Preeti from CodeMatrix. Now I'll be explaining the objectives of our project titled AI Driven Multi Robot Fleet Management System for Autonomous Hospital Operations. Objectives are very important in any project because they define what we aim to achieve and how our system will create real world impact. Our project focuses on improving hospital efficiency, safety, automation using artificial intelligence, and multi robot coordination. The first objective is to automate hospital logistics using intelligent robots. In hospitals, staff spend a lot of time transporting medicines, lab samples, medical equipment, and patient records. These tasks are repetitive, time consuming, physically demanding. Our goal is to design a system where robots can handle these deliveries autonomously and efficiently. By using artificial intelligence, the robots can understand task priorities, choose optimal paths, avoid obstacles, and reach destinations safely. This, this automation helps reduce the workload of nurse hospital staff, allowing them to focus more on patients can and rather than manual transportation tasks. The second objective is to enable smart coordination between multiple robots. The second objective is that in real hospital environments, many robots may operate at the same time without proper coordination. This could lead to congestion, collision, or delay. Our system aims to assign tasks dynamically to avoid robots and monitor robot locations in real time, prevent route conflicts, and optimize all all over moment efficiency. This ensures smooth operation across different hospital departments such as emergency wards, pharmacies, laboratories, and patient rooms. The third objective is to improve safety, accuracy, reliability in operations. Another important objective is to increase operational safety and reliability, reduce human errors in deliveries, minimize physical contact where not necessary, and provide accurate tracking of medical items and maintain consistent performance throughout the day. AI algorithms help the robots make safe decisions, detect obstacles like patients or equipment, and respond to unexpected situations quickly. The fourth objective is to support scalability and future smart hospital integration. Our final objective is to build a system that is scalable and future ready. As hospitals grow and technology advances, more robots and new features can be added. Our design supports easy integration of new robots, expansion of new departments, and compatibility with other smart hospital systems such as IoT devices and electronic medical records. This ensures long term usefulness and adaptability of the solution. To conclude and to summarize, the main objective of our projects are to automate hospital logistics using AI-driven robot to or to coordinate multiple robot efficiency through fleet management and to improve safety, accuracy, reliability, and to create scalable system for future hospital needs. Through these objectives, our project aims to contribute towards building smarter, safer, and more efficient hospitals using artificial intelligence and robotics. Thank you.
Hello everyone, we are Core Matrix and this is Tripujita. I will explain the architecture and tools behind our AI based hospital robot fleet simulation step by step in a very simple way. So, before building real robots, engineers always design an architecture. Why? Because our architecture tells us who decides, who coordinates, who moves, and where everything happens. In our project, the system is divided into layers, where each layer has a clear responsibility. Let me start from the top layer, where intelligence lives and moves down to the execution. This is the brain of the system. Here, AI algorithms decide what tasks should be done, when, and with what priority. For example, should a robot deliver medicine first or carry lab samples? Which task is urgent? We implemented this logic using Python and Jupyter notebooks, where we tested task scheduling, optimization, and prediction models. Once decisions are made, we need a coordinator. That's where fleet management layer comes in. This layer decides which robot should do which task and avoids conflicts when multiple robots are working together. For this, we use OpenRMF, which acts like a dispatcher and controller for robot fleets. Now, all components need to communicate. That's handled by middleware layer, powered by ROS2. ROS2 allows robots, navigation systems, and fleet managers to exchange messages reliably in real time. You can think of ROS2 as the nervous system of the entire robot ecosystem. Once a robot receives tasks, it must move safely. That's handled by the navigation layer using nav2. Nav2 plans paths, avoids obstacles, and replans roads dynamically if something blocks the way. It's basically like Google Maps for robots. Testing robots directly in hospitals is risky and expensive, so we use simulation. This simulation layer uses Gazebo with the Turtlebot 3 robot model to create a virtual hospital environment. Here, robots moves, senses obstacles, and interacts, all safely inside a virtual world. Finally, we need visibility. The monitoring layer shows robot positions, task status, and performance metrics using tools like RWAYS, logs, and dashboards. This layer doesn't control robots, but it helps humans understand what's actually happening. And here is a quick summary of the tools we used in this project. ROS2 for communication backbone, Gazebo for simulation environment, Turtlebot 3 for robot model, Nav2 for autonomous navigation, OpenRMF for multi-robot fleet management, Python and Jupyter for AI logic and analysis. Each tool solves a specific problem and together they form a complete system. This architecture is important because it reflects real world robotic system. The same design principles are used in hospitals, warehouses, airports, and smart factories. Simulation first development reduces cost, improves safety, and allows AI models to be validated before deployment. This project is not just about robots, it's about AI, coordination, and real world problem solving. If you found this explanation helpful, like the video, subscribe to the channel, and comment if you want a demo of the simulation or AI models. Thanks for watching. See you in the next video.